Hey there, Adrian here from PyImageSearch.com, and today we're going to learn how to do basic drawing using the OpenCV library. Specifically, you'll learn how to draw lines, rectangles, and circles using OpenCV, and we'll also teach you how to draw on images as well as, a blank empty canvas. So you're going to get a good review of not only drawing with OpenCV, but drawing on actual images and then initializing an empty canvas and drawing that as well. So let's take a look what we have here in terms of a project directory. We have two Python scripts to review today. Basic drawing.py. This will show you how to initialize an empty canvas using NumPy and then draw on it using circles, rectangles, and lines. And then we also have image drawing.py here. Now this script, what it's going to do is load this adrian.png image, and then we're going to draw on it using the cv2.rectangle, cv2.line, and cv2.circle functions. So you'll gain some experience using those functions on actual images as well. So with that said, let's pop over here to PyCharm. We have our project directory structure already loaded up here, and I'm just going to open up basic drawing.py. So we can see all of our code here, and we're going to walk through it line by line to ensure you have a really good, strong understanding of how these drawing operations are performed using OpenCV. So the first thing I'm going to do is import NumPy. And we're not using NumPy really for numerical processing or using it for its deeper functions. We're instead just using it to initialize empty blank canvases that we can draw on. Because keep in mind, once an image is read via the cv2.imread function, OpenCV represents it as a NumPy array. So as long as it's a NumPy array, you can use any of OpenCV's functions on top of that array. So what you can see right here, we're initializing a blank empty canvas. This canvas is 300 pixels wide by 300 pixels tall and has 3 channels for each of our red, green, and blue channels. Now, this zeros function indicates that this array with these dimensions is going to be filled with zeros. So that's going to be a black background. And notice the D type, the data type. OpenCV represents images as unsigned 8-bit integers. So all we have to do to create this blank empty canvas is to set our data type to an unsigned 8-bit integer as well. So that's all there is to it. That's how we initialize an empty array that we could draw on. So from there, let's start digging into the drawing functions. First, we define a green tuple. Now, keep in mind, we typically talk about images in red, green, and blue channel ordering. However, in OpenCV, they're actually represented in the reverse order. You talk about them in blue, green, and red, BGR order. So why is it that we talk about images and colors in RGB order, but OpenCV uses BGR? Well, that just goes back to when the OpenCV library was developed over 20 years ago. During that time period, it was actually more common to use BGR ordering. It was only until later that image processing and computer vision practitioners started using the RGB ordering more. So this is just a relic of an older time in image processing. But if we were to try and switch everything over to RGB ordering now, that would mean that everything that we have developed over the past 20 years would have to be updated as well. So that's just a little caveat for you to keep in mind when we're using these drawing functions. Just keep that in mind, and you'll be totally okay when working with OpenCV. So what we're doing here is defining a color green. So this is the green bucket's fully filled up, the red bucket zeroed out, and the blue bucket is zeroed out. And what we're going to do is we're going to draw a line on our canvas, our empty canvas, which we initialized up here, starting at 0, 0, which is the top left coordinate, and then drawing it all the way down to the bottom right, which is 300 and 300. And this is going to be a green color line. And then we're going to show this canvas to our screen. Now, typically, I review the entire script before popping over here to the terminal, but for this example, it's actually more beneficial to run it as we step through the code so you can see exactly what it's doing. So I'm going to paste this usage over here, and I'm going to execute the script. So here, you can see we've drawn a green line starting at the origin, the top left, 0, 0 of the image, and it goes to the bottom at 300, 300, the bottom right corner. And notice this line here is 1 pixel thick. What if we instead wanted to draw a 3 pixel thick line? What will we do then? So let's take a look. We'll initialize a red color with the red bucket fully filled up, 0 for green and 0 for blue. And this time we're going to draw it from the top right corner to the bottom left. So the top right corner is up here, and then we're going to draw it to the bottom left, which is down here. And again, it's going to span the entire width. We're going to draw it with a red color, and it's going to be 3 pixels thick. And then we're going to display that to our screen. So go back over here to the script, move it forward once more, and sure enough, here is our red line that extends across the entire width of the image. So as you can see, drawing a line with OpenCV, super simple. Here's the exact recipe you follow. The first parameter is your canvas or your image, what you're going to be drawing on. You have the starting point of your line. This is the XY coordinate of where you want your line to start. Then you have your ending XY coordinate of where you want your line to end. You specify the color that you want your line to be, and optionally, you could specify a thickness in pixels for the line. Let's move on to drawing rectangles. So what we're going to do here is draw a 50 by 50 pixel square, and we're going to draw it on the same canvas. The top left coordinate of the rectangle, this CV2.rectangle function is very similar to the line function, except you want to pay attention to these parameters the most. This first one, this is your top left corner of the rectangle, and this one is your bottom right corner of the rectangle. You then specify the color of the rectangle. So reading this comment, you might be a little confused and be like, wait, how is this 50 by 50 pixel square? Where did you come up with that? Well, look here. This is the ending coordinates, so 60, 60, and these are the starting coordinates. If you subtract the two, you get 50 by 50 because 60 minus 10 equals 50. So that's how I know it's a 50 by 50 square. And we'll display our square to our screen. So coming back here, execute the script once more. Sure enough, we have a green rectangle that is 1 pixel thick, 50 by 50, starting at x equals 10, y equals 10, and ending at x equals 60, y equals 60. So just like we can control the thickness of a line, we can also control the thickness of a rectangle. So here we're going to again draw on our canvas, supply our top left corner of the rectangle, supply the bottom right corner of the rectangle, and indicate that this is going to be a red rectangle, 5 pixels thick. And again, we're going to display the output of drawing. So sure enough, here we have our rectangle with a 5 pixel thick border surrounding it. So looking at this, so far with rectangles, we've only adjusted the thickness. What if we instead wanted to fill it in and make it, whole and complete versus just having an outline? That's as simple as supplying a negative value for your thickness. So here we're going to define this blue color, and we're going to draw our rectangle, and the -1, again, is going to indicate that this should be a filled in rectangle. And sure enough, here you can see that our rectangle has been filled in just by supplying a negative value for the thickness. So that's it for drawing rectangles and lines. Let's see how we can draw circles. So we're going to reinitialize our canvas. So previously we had all these lines of code up here, had drawn lines and rectangles. We're going to reinitialize it so it's empty and blank. And then we're going to compute the center XY coordinates of the image and then create a white color. And then we're going to start a for loop ranging from 25 pixels to 150 pixels with a 25 pixel increment. And at each step, we're going to draw a circle. The circle is going to be drawn on the canvas. And then here is where we specify the center XY coordinates of the circle. So this is where the center point at which the circle will be drawn around. And here is the radius of the circle. So from the center, you're going to pick the radius, and then it's going to draw all the way around and complete itself, almost like when you were playing with a compass or in like your basic algebra class or geometry class back in middle school. That's all that you're doing here is you're taking that center point and then specifying your radius, and then you just swoop around. That's all that's going on there. And we're going to draw this as a white rectangle. So we're going to do that in incremental steps, and then we're going to show our work. So go over here, run this, and it kind of creates this bullseye effect. So this is what happens when you're just drawing essentially a tiny 1 pixel circle located at the center with a 0 radius. It's just this singular dot. But then as we increase to 25 pixels, this is what the circle looks like. Here's 50, 100, etc., all the way out to 150. So it creates this little bullseye. And then for fun, let's see how we could use random values to draw circles. So we're going to reinitialize our canvas once again as an empty 300 by 300 image, and then we're going to draw 25 random circles. So we're going to first generate a random radius. This radius is going to be between 5 and 200. And then we're also going to generate a color. So keep in mind, colors in OpenCV are just a tuple in blue, green, red ordering. That's all we're doing here. We're saying generate me a random value between 0 and 256. The 256 is not inclusive, so the maximum value will actually be 255. And we want 3 of these values in the range from 0 to 255. And let's convert that from a NumPy array to a list. If you don't explicitly convert the color to a list, OpenCV could potentially throw an error. So make sure you do that list conversion. And here we're specifying the center XY coordinate, the point in which we're drawing the circle around. So we're going to specify a random center of anywhere between 0 and 300, which is the maximum size of our canvas. And we want 2 of these values because, again, we want an XY coordinate point, hence 2 values instead of 1. So given all these random values, we're going to call the cv2.circle function again, passing in our canvas. We'll pass in our point, which is the center XY coordinate, the radius of the circle, the randomly generated color of the circle, and then we specify a negative value here because we want that circle filled in. And then we'll show the results of our work over here. So I'll advance the script, and here you can see we've just drawn a bunch of random circles. You don't see all 25 circles here because, depending on what random values are generated, you could draw over previously drawn circles, so you won't see all 25. And I'll run this script again so you can see the output and see and verify that it's different. So like based off of this random output, we can only see parts of 3 circles. And if I draw it again, here's a separate output. So it's demonstrating that these random circles are being drawn. So that's it for drawing on like a pre-initialized canvas. What if you wanted to instead draw on this image right here? How would we go about doing that? Well, let's answer that question. Let's take our newfound knowledge of drawing with OpenCV and combine it with what we've learned in previous tutorials, namely how to load an image from disk. So we start off with our imports, argparse for command line arguments, CV2 for OpenCV bindings, and then we'll parse our arguments here. We only need a single switch, which is image, the path to our input image on disk. I set this as a default value to adrian.png, which is included in our project directory structure. And then once our command line arguments are parsed, we load the image from disk using cv2.imread, and then we draw 3 circles. The first one is going to be around this first circle here is going to be centered on my face, and it's going to be covering essentially my mouth. And then we're going to draw 2 more circles. These ones are going to cover my eyes, and they're not going to be filled in. And there's going to be a rectangle or a bounding box drawn around my face as if it were detected. And then we're going to show the output to our screen. So let's go ahead and execute this script. And here you can see we have this circle drawn around here. I accidentally said it was a rectangle. That was my fault. So let's go back and re-explain this code. So first what we're going to do is we're going to draw this circle surrounding my face. So this circle, the center is probably right here around the center of my nose. We specify the radius, and that swings around and draws the circle. Additionally, we're going to draw 2 more circles, these ones over top of my eyes. Notice that these 2 circles are filled in because we specified a negative value for the thickness. And we have this rectangle here covering my mouth region, again with a negative value for the thickness, which indicates that the rectangle is filled in. So looking at this code and looking at the output image, you're like, wow, like how did you know like that's where to place the center of the eyes and for the mouth, and then how did you know this coordinate so you could specify the proper radius? Well, basically what I did there was I took this adrian.png image and then I opened it up in like Photoshop or GIMP or Paint or Preview, whatever my favorite photo editing software was, and then I just manually used my mouse to hover over and find the XY coordinates of that particular pixel. And once I had that, then I could come over here and just plug in the values to the circle or rectangle calls respectively. And that's all there was to it. But of course, you might be thinking, what if I wanted to automate this procedure? What if I wanted to generate this image automatically without having to load up an image in Paint or Preview or Photoshop? How would you go about doing that? Well, that's a series that's a specialized topic called, object detection. In this case, working with faces. So you would apply like a face detector to first detect the face. And once you had the face, you can compute the center XY coordinates, and then you could draw the circle. Then for the eyes, there's specialized algorithms that you could apply for eye detection. There's pre-trained hard cascades that can detect eyes, or even better, use facial landmarks. And we have a whole number of tutorials on facial landmarks here that I highly suggest you read. And we have entire courses generated that discuss them. But as a little preview, here's an example of facial landmarks. I'll open this image up for you. And here you can see a detected face. And then we also have been able to detect the chin region, the mouth region, the nose, the eyes, the eyebrows. And that's something you'll learn how to do, in future lessons, or you can go check out these articles which cover that topic in depth. So, again, this is more of a walk before you run here. We're just learning the basics. Once we get a firm foundation, once that concrete has been formed and settled and poured and just ready to go, the rest of the structure will start to go up quickly. So, we're learning the basics first, and then once we've understood these basics, we'll move on to the more advanced concepts. But for the time being, download the code to this guide, play with it, make sure you understand the arguments that you need to pass to the line, the rectangle, and to the circle function. And as long as you understand that, you have enough understanding to continue on with the next lessons. I'll see you later.